In today's code example, I want to walk us through how I was writing integration tests to assert the different APIs that I have in my ASP.NET Core application, and how I went about querying for all of the registered routes, and then how I wrote tests to actually go assert that things like rate limiting and authentication were all set up as I would expect. So let's jump over to Visual Studio and I'll explain more in detail. In my previous ASP.NET Core videos, I actually used a sample application, but in today's video, I'm actually going to use a real application that I've been building, and I figured this would be a really good example to walk through because it's actually a real thing that I'm trying to do for my own API. So I'm going to gloss over some of the details that we'll see on the screen here just because they might not be totally relevant, but in case you're interested in mimicking some similar behavior, I'm going to point them out, and then that way you can go look into these more in detail or ask questions about them in the comments, and I'm happy to answer more. For my tests, I actually love using xUnit. I know there's a million different flavors of testing frameworks, but for me, xUnit's always check the boxes. So I do have a couple of traits, which are just really these different attributes we can assign for xUnit tests. I just have them for my own integration suite, and honestly, at this point, because I've switched over to Azure DevOps, I don't really need these, but this was for a different platform where I had less luxuries to work with. In my particular case, because my application needs things like different databases set up, and I want to make sure that I'm not accidentally tampering with production databases and being able to write to those, I actually have these different test fixtures set up, and because I'm actually querying my API in a lot of my tests, I have this other class fixture as well, which just gives me a web client to go interface with it. So these are all very specific to my needs. And then if we go down a little bit further, you'll see some of the setup that I use in my integration tests. And again, I'll just quickly gloss over it, but we can see the fixtures being passed in here. So these just need to correspond with these iClass fixtures up top, and that's an xUnit thing. And then what I do is I use this builder pattern where I can actually have this nice syntax where I can say that I want to use a local server port, and then I can go actually configure my application to use my MySQL container and a MongoDB container. So behind the scenes, I actually have Docker images through test containers spun up to go make this work. And that works really well for all of my integration tests. And then I do some authentication setup. And then this other part down here is just so that I can wire in some of my app startup stuff to actually query for my routes. And in particular, this is actually one of the most important parts out of all of this setup code that is going to be relevant for the rest of this video. But I wanted to touch on all these other pieces just so you can understand what's going on. And if you think it's interesting, then you can ask about it. So why is this part really useful for us? Well, let's jump down to this class, which I have down here. And we can see that I have this ensure rate limiting, and this is really the test suite that I'm trying to set up here. And I have this interface called iWebAppPostRunWork. And in my particular case, this ends up getting called once I start my ASP.NET Core application, and because I'm running that asynchronously in this other method that I have, I go run any registered iWebAppPostRunWork interfaces that have been registered through AutoFac. And once the app is started up, I run all of these that are registered, and then I await on the task, which is the app being started. And the reason that I do this is because when we want to go check for the endpoints, which I have in a previous video, I demonstrated that the method I'm using, which I will scroll down to right here, actually requires that the application is started. If we try to run this particular code any point before the application has started, I don't get back any endpoints. And what I've observed is that because I'm using minimal APIs in ASP.NET Core, a lot of the other methods that I saw online that seem to be all of the Stack Overflow answers suggested things that just don't work with my minimal API registration. So being a little bit frustrated, this is the solution I came up with. And just to kind of circle back, all of this ends up getting registered through AutoFac. And when my application starts up, it goes through the list of all of these that have been registered, this iWebAppPostRunWork. And in this example, I only have this single one. And what it's going to do is when it calls this doWork async, it will go ask for all the endpoints, and this is where we actually have the body of our test. Now, when I say that, you might have caught that if I scroll back up, we're inside of a private class here. And if you're familiar with xUnit, you might be saying, well, Nick, that doesn't make any sense at all. How could you possibly have an xUnit test inside of a private sealed class here? Because you need to label all of your xUnit tests with either a fact or a theory attribute. And you're right, you do. But if I scroll up a little bit further, we can see that I actually do have this fact, and I'm using a bit of a hack for how my application is set up. But if I go call this particular line of code, the instantiation of getting an API client for me actually enforces that I have a web application started up. In my case, instead of trying to expose the web app and doing some funky stuff, I actually have all this other integration test stuff set up so that when I want an API client that talks to the web app, I actually have to start it. And because this was already written, the really cool part is if I just ask for this API client, it will literally go start the server to go get me this API client. And just by starting the server, if you think back to what I said a few moments ago, that means that this has to go get run. So yes, this is a little bit of a hack. In your case, if you were able to get the web app, you might be able to say var app equals, and then I don't know how you would go get it if you're using autofac. You might have a lifetime scope. You could do something like lifetime scope or lifetime resolve, and you go get your web application. I don't know what the class actually is, but you might have something like this, right? And then after you do app.start, I think it's called run. And this actually blocks, so you can't use this. You would have to use this type of syntax here. You say run async, and then we would get the routes here, and then you would await on the task here, or you could do something like app dot, I think it's stop is the syntax as well. So anyway, the point is that in my particular case, this is a bit of a shortcut, and because you don't have the same code base as me and the same setup, if you want to accomplish a similar thing, you might want some syntax like this. Again, I don't know if you're using autofac or whatever else you want, but you need to get an instance of your application set up. And then I'm just going to demonstrate my point, you would have something like this here, and then write your test. Thank you, autocomplete, for that. So yeah, it would look something like this. Okay, so you likely want some type of setup like this, but that's not what I have. And I'm just gonna, now that I've made that point, to actually go through and show you what my body of the test is actually asserting in this particular case. So if we scroll down, when we get these endpoints, for my particular application, I only want to be writing some tests that operate on my post and get methods. I don't have anything like delete or put or any other HTTP methods at all, so I'm not worried about those for now, but I do actually have some signal R stuff registered, and that ends up showing up on some routes, and right now I don't want to assert that stuff, so I actually will go skip over anything that is signal R. We can see that down here. I have this check for is not signal R. But what I am interested in is actually checking for rate limiting attributes. So when I've been writing my routes, I actually want to ensure that everything that I have registered actually has one of these rate limiting attributes on them. The reason that this is really important for me is because if I want to be able to expose my API for public consumption, and let's say that I want people to pay for it, I want to ensure that everything is properly rate limited. Now, the other challenge that I have is because I work a lot with plugins. In my particular case, I have a lot of vertical slices for my web app, and all of them are organized into plugins. And each plugin is able to register different routes. So because it's kind of distributed, I wanted to have a single spot. So this is actually an integration test that will run on my main app, not per plugin, and it will go create the whole app with all of the plugins loaded that I would have in production, and then it will go ask for all of the routes. And then what we're trying to do is checking to see if we've properly configured each route with rate limiting. So I just have a check here that says if we have basically more than one rate limiting attribute, which is not going to make any sense, it will compile. I think it actually runs, but I don't know what the expected behavior is. So I just enforce that we can't have more than one. And then if it's not signal R and we don't have any rate limiting attributes, I also want to fail and make sure that I can basically stop myself from accidentally committing any routes that don't have rate limiting. This test is actually pretty simple when we look at what's actually happening under the hood, but the complex part was really just that I needed a way to be able to query for the endpoints. And because of how all of my application is set up, if I scroll back up a little bit more, I have some of that buried in here, but like you saw earlier in the video, I demonstrated how you could go new up a new instance of your web app and then essentially go run all of this stuff right inside the body of your test. So hopefully you found that useful. I found that I've been writing more styles of tests like this recently to basically go check over all of the different routes that I have in my application. So this example, I demonstrated the test that I'm using to go look at rate limiting. I do plan to have the same thing for authentication, although I do have a couple of routes that are not required to have auth on them. So I need to find a way to go balance that properly. And then the next thing that I'm doing is actually trying to make sure that I have documentation properly set up. And I'm going to make a follow-up video on that, which I will end up linking to this one. And what we're doing in that code is actually going to look at the Swagger documentation that's output and linking it in a similar way to the test we just looked at and ensuring that we have the right XML defined in our output. So thanks so much for watching. Hope you enjoyed, and we'll see you next time.